Hello everyone, we are doing Scholarship Calculus 2023, question 2C. Euler discovered an exponential equivalent polar form for complex numbers. He found that any complex number z equals r c I theta could be written in the form z equals r e to the power of I theta. From this, it can be shown that e to the power of I theta equals cosine theta plus I sine theta. Use this identity or otherwise to, number one, determine the exact real value for I to the power of I squared. First of all, Euler is my favorite mathematician. He contributed in math so much. Okay, now, so I to the power of I squared. I believe we have to change I into polar form, right? So I being over here, isn't it? One. This is the imaginary part, isn't it? And the real part. So what is I as a polar form? So R is 1 and CIS that much, which is pi over 2, isn't it? So it says it can be written CIS 1 CIS pi over 2 can be written 1 e to the power of I pi over 2, right? So, well, this is simple question, isn't it? So what all you have to do, e to the power of I pi over 2 to the power of I, and then you square it. So what happens? When you times by I, you have e to the power of negative pi over 2, and then you square it. So what do you have? E to the power of negative pi should be the answer, right? Question 2, write the complex number natural log negative 25 e to the power of I to the power of I in exact rectangular form. Alright, we have to use a log rule. So you know you can split because it's times. So I can rewrite as natural log negative 25 plus natural log e to the power of I to the power of I. Right, I can tell this is just I to the power of I, isn't it? Natural log e is just 1. And that one, the front part, I can rewrite natural log 25 times by negative 1, which is plus ln minus 1, isn't it? Right? And as I said, this is simply I to the power of I. Hold on. We've done this I to the power of I. So that was question 1. What have I got? I is e to the power of I pi over 2 times by I is e to the power of negative pi over 2. So I'm going to repeat this. And I to the power of I is simply e to the power of negative pi over 2, right? Now, what's adding negative 1? Look, negative 1 stays here. So as polar form, it is R is 1, right? So negative 1 is equivalent to 1 CIS that much, which is pi, isn't it? So in other words, in Euler's form, Euler's polar form, so e to the power of I pi, right? Yeah. So I can rewrite that. Then what happens is ln 25, ln negative 1 is equivalent to, yeah, I'm going to write it, I pi plus e to the power of negative pi over 2. Now, I'm going to sort them out. So ln 25 plus e to the power of negative pi over 2 must be real part. and when it comes out, it becomes I pi. Hold on. I believe we have to say, instead of just I pi, because it repeats, it can repeat, I mean. So actually, you have to say pi plus n pi, isn't it? 2n pi, right? So when you repeat, so when I make one revolution, it's the same place, and then I can make pi or 4 pi, so on. So I have to add 2n pi, I believe. So I have to add over here 2n pi. So instead of saying I pi, I would say I bracket plus 2n pi. Okay. So that's the exact polar form, isn't it? So that front part is rear part, and pi plus 2n pi should be imaginary part. So that should be the answer for question 2. All right. I will see you next time. 안녕.